This is the CLD Success Package video covering File I/O. We'll take a look at File I/O in the exercises. We'll see how files are accessed, and we'll see how file accessing sub-VIs are used in a broader application. My name is Mark Ramsdale. I'll be the host today. Exercise 5 covers the use of the configuration file format. We see that the solution is a functional global variable with two modes, get and set. Labview provides the configuration file sub-VIs. It is imperative that you use these to access the INI file. Using another method will take too much time to develop in the CLD exam. We see that there are keys that have hard-coded names, and the data types are chosen ahead of time. This is very appropriate. Similarly, in set, we hard-code the key names. For this example, the data that is in the file includes the location of the data sets within the array. When the data is read from the file, it is placed into an array by using a typedef cluster. The location in the array is taken from the index values, two of the keys, from the file itself. Exercise 6 covers the comma-separated variable, the CSV file format. This functional global variable has two states, read and write. In the read state, the data is retrieved from the file, and the logic for the model, including the typedef cluster, allows the data to be put into a format that can be used by the application. In the write state, the data coming in is sorted out into the order that it should be placed into the CSV file format. For this particular model, we take an extra step to ensure that the capitalization does not become a problem for our text strings, both on reading and in writing. Exercises 10 and 11 both use the CSV file format. They have the same functionality in terms of their requirements to read the data from the file and to expose that data to the rest of the application. In exercise 10, simple state machine, in the read state, the read case, the CSV file looks very similar, in fact almost identical, to the initial CLD exercise we've shown. Even though this state has a read and write, only the read is used in this application. Of course, when you're taking the CLD, if you don't have a requirement for writing, you should not develop that part of a sub-VI. Exercise 11 uses the same sub-VI in one of the states in the consumer, in that portion of the producer-consumer application architecture. In both cases, a sub-VI is used to help distribute the data that has been read from the file. You can see there are many outputs, and it would be very cumbersome to put all of these outputs onto the functional global variable that reads the file data. Exercises 8 and 12 both use the CSV file format. In exercise 8, there is a read function only. The typedef is used to help organize the data into a structure, and these clusters are passed into an array. This exercise is a sub-VI utility that includes a command field and 4 other fields that have state data. Ideally, this command could be used in a step or sequencing state machine. In application number 12, we see that there is a queue-driven state machine. The file I/O is performed in the start case. The utility is very similar to exercise number 8. However, the command field is converted into an enum. This allows the start state to index all of the data and place it into the queue, calling out the different cases. For example, the run state case uses some of the state data, and similarly the set time case uses some of the state data. This use of file I/O in a sequencer allows the user to create different text files that would command their application to perform different steps or steps in different orders or some combination thereof. Exercise 15 covers both reading and writing for CSV files. In Exercise 15, the file data is read, it is converted, then it is formatted, and then is written to a different file. If this file was a configuration file, the read file and write file sub-VIs provided by Labview would have to be replaced with a utility that could handle the INI file format. The challenge portion of exercise number 15 is to take the same functional requirements and create a sub-VI that is a functional global variable. We see here that the read has the same functionality as the original VI. We'll find that's the same for all of the states. Creating the functional global variable allows the file I/O to be distributed throughout an application. It modularizes the actions for file I/O and it provides them in a convenient sub-VI. If the file format requirements were for a configuration file, we could change these states with the appropriate logic and the appropriate utilities to read and write to access the INI files. We have covered strategy for file I/O in the CLD exam. Here are some points to remember. When you first read the specification for your exam, you will quickly determine the type of file that is used for the application. Next, as you read the model, you must consider when will the file be accessed and what kinds of access do you require. Is it only reading? Is there reading and writing? Will there be multiple writes throughout the application? After that, you must determine how will you implement the file I/O module. Will it be a standalone functional global variable, or will you place all of the file access functionality inside the main VI? The final point is to consider the type of data used by the application and the format of the data in the file. It is most likely that you will need to convert the data read from the file and possibly convert the data created in the application to a format for a file. Considering all of these factors should allow you to create file I/O module within about 20 minutes during your CLD exam. For the overall CLD exam strategy, the file I/O module must be addressed early. You should be familiar with the mechanics of reading and writing to the different file types. Spend your time analyzing how the data is used in the application and how conversion and formatting will be used, and where file I/O access will occur.